Okay, students, let us solve the questions on electrical measurements and measuring instruments in the same question paper Dcet 2019. Question paper code EE, branch electrical and electronics, version is H. Okay, part C. So everything is same, but electrical measurement and measuring instruments is the subject. So in that, question number 100 says the minimum number of wattmeters required to measure 3-phase, 3-wire, balanced or unbalanced power is dash. So question I will read again. The minimum number of wattmeters required for the measurement of 3-phase, 3-wire, balanced or unbalanced power is dash. So option A 1, option B 2, option C 3, option D 4. Okay, so we can see this diagram, circuit diagram for the measurement of 3-phase power. Okay, here we have used how many wattmeters? See, so this is 1 wattmeter, so this is 1 wattmeter, this is another wattmeter, and this is the 3-phase balanced or unbalanced load. This is the balanced or unbalanced 3-phase load, right? For the 3-phase load, how many wattmeters we have used? See, this is wattmeter number 1, this is wattmeter number 2. Current coil, voltage coil, current coil, voltage coil. Means these are the parts of wattmeter. So only 2 wattmeters we have used. So which option is right? Option B, 2 is the right answer. So the minimum number of wattmeters required to measure 3-phase, 3-wire, balanced or unbalanced power is 2. Okay, option B is the right answer. Okay friends, let us move on to the next questions on the measuring instruments, electrical measurements and measuring instruments. Question number 101 says, in an indicating instrument, the damping force acts on the moving system only when it is dash. Okay, see the option. First option is A, stationary, second, moving, C, near its full deflection, fourth, just starting to move. Okay, so damping force is the force acting on the moving body. Okay, if a pointer is moving in this way, damping force acts in this direction since it comes to rest. If it is measuring 5 volts or 5 amps, whatever it may be, so if it is indicating 5 amps, so damping force acts in the opposite direction to the pointer in order to make it stop there at the calibrated mark. Okay, so damping force acts on the moving body only. Okay, it acts only when the body is moving. Okay, which option is right? Second option, B, moving is right. Means in an indicating instrument, the damping force acts on the moving system only when it is moving, not at rest, not at full deflection, not at just starting to move. It acts only when it is moving. Okay, and also when it is at rest also, it doesn't act on the body. Okay, only when it is moving, it will act on the pointer. Okay, so next question 102. Permanent magnet type instruments are used to measure. See the options. Option A, both AC and DC. Option B, only AC. Option C, only DC. Option D, neither AC nor DC. The right answer for this question is only DC. Okay, so since permanent magnet type instruments will be having this pointer, if we use it for AC, what happens? The direction of rotation of this pointer will takes reversal when the alternating current changes its direction. Okay, so when the current direction is in positive cycle, pointer will move in this direction. But again, when alternating current changes its direction from positive cycle to negative cycle, this pointer will again move backwards. So but in DC, pointer will move only in one direction to measure the current or voltage in DC measuring instrument. So permanent magnet type instruments are used to measure only DC. If they are used in AC, the pointer will deflect on each cycle of the alternating quantity. Okay friends, let us solve some more questions on electrical measurement and measuring instruments topic. The question number 103 says, which of the following instruments cannot be used for measuring DC? The question is, which of the following instruments is not used for measuring direct current? Means the DC quantity. First option, induction type. Second option, hot wire type. Third option, moving iron attraction type. Last option, moving coil permanent magnet type. Okay, so these are the types of measuring instruments. So the first one, induction type. Second one is hot wire type. Third one is moving iron attraction type. Last one is moving coil permanent magnet type. Okay, so for the measurement of DC, there should be large flux should be linked with the pressure coil with the current coil. See, consider this wattmeter. So this is the current coil. This is the current coil, and this is the potential coil. Okay. So these are the terminals. Okay, this is the current coil and this is the potential coil. Okay, in order to measure the DC power or the power, there should be a flux linked by this current coil to this potential coil. In the hot wire type also, there will be a large amount of flux linked with this coil. In the moving iron attraction type also, there will be a large flux linking, and moving coil permanent magnet also, there will be large flux linkage between those coils. But in induction type, what happens? Induction type, small current will flow in this current coil, hence less amount of flux is linked with the flux will be less. So flux linking will be less in the induction type of measuring instrument. So for measuring DC current or DC power, induction type cannot be preferred, since there is a less flux linkage with the coils. The pointer will be at the zero position only, so quantity cannot be measured. Hence, induction type instruments cannot be used for measuring the DC quantity. So option A, induction type, is the right answer. Moving on to the next question, 104. Which of the following laws will not be present in dynamometer instrument? Which of the following laws will not be present in the dynamometer instrument? Okay, oxide options, copper loss, eddy current loss, hysteresis loss, air friction loss. Okay, dynamometer means it is associated with electromagnetic field. Okay, where there is electromagnetic field, all these copper loss, eddy current loss and hysteresis losses will be present, because dynamometer type will be associated with electromagnetic induction or electromagnetic field. Where there is electromagnetic field, copper loss will be there, eddy current loss will be there, hysteresis loss will be there, but air friction loss will not be present. Okay, so the loss which is not present in the dynamometer instrument is air friction loss. All these losses will be present, but air friction loss will not be present. So option D, air friction loss, is the right answer. Okay friends, let us solve some more questions on electrical measurement and measuring instruments. Question number 105 says, the range of moving coil ammeter can be extended by using, okay, the range of moving coil ammeter can be extended by using option A, high resistance multiplier, option B, high resistance shunt, option C, low resistance in shunt, option D, low resistance multiplier. Okay, Suppose this is the initial resistance of this ammeter, and this is the initial current which is to be measured. Suppose we need to extend the range of that ammeter. Suppose if it is measuring 10 amps, that if that has to be made to measure 100 amps, what we need to do? That's the basic question right now. So using high resistance multiplier, it is not possible. Using high resistance in shunt, okay. So these are the options: low resistance in shunt, low resistance in resistance multiplier. The right answer for this question is low resistance in shunt. See, this is the equation: RSH equals to Im Rm divided by I minus Im. Okay, so this is the initial current, and this is the current to be measured, which is large. Since this is large, denominator is large. Since the denominator is large, obviously numerator is small here, because this is the small current and small resistance. When the denominator is large, numerator is small, obviously this will be small only. So low resistance in shunt, here we have connected in shunt. So this is the circuit for extending the ammeter range. Okay, this is connected, RSH is connected to Rm in parallel. So low resistance, by this equation that RSH value should be low, and by this circuit we can say it should be connected in shunt. So the range of moving coil ammeter can be extended by using low resistance in shunt. So this is the answer, C option, low resistance in shunt is the answer. And the next question is, the normal ratio of the current transformer is: option A, rated secondary winding current to rated primary winding current; option B, rated primary winding current to rated secondary winding current; option C, number of secondary winding turns to number of primary winding turns; option D, number of primary winding turns to number of secondary winding turns. Okay, the option C is the number of secondary winding turns to the number of primary winding turns, means N2 by N1. N2 by N1 is the turns ratio. This is turns ratio. So that is not the answer. Rated secondary winding current to rated primary winding current. So turns ratio can be given by N2 by N1 equals to V2 by V1 equals to I1 by I2. Okay, so that should be equal. But rated secondary winding current to rated primary winding current is not the answer. See there, rated primary current to rated secondary winding current, this is the answer. So the normal ratio of a current transformer is given by rated primary winding current to the rated secondary winding current. So option B is the right answer for this question.